Hey there, and welcome. Today, we're going to talk about turning your basic Python scripts into something way more powerful. We're talking well-organized, crash-proof programs. And we're going to do it by mastering two of Python's most essential power tools, functions and exceptions.
Look, we have all been there. You write a piece of code, it works, so you copy it, and then you paste it somewhere else, and before you know it, your script is this tangled mess. And then all it takes is one weird user input to bring the whole thing crashing down. It's super frustrating, right? Well, what if I told you there's a way to tackle both of these problems at the same time?
So, our first tool for the job, it's the function. I want you to think of it as the ultimate organizer for your code. It's how we take all that chaotic, repetitive logic and wrestle it into something that's clean, efficient, and honestly, incredibly powerful.
You know, at its core, a function is actually a really simple idea. It's just a named block of code that does one specific thing. The beauty is, you define it just once, and then you can call it or run it as many times as you want from literally anywhere in your program. Say goodbye to all that copy-pasting. And this is where you really see the magic happen. On the left, you've got the same lines of code repeated over and over. Just imagine trying to update that. It's a total nightmare. But look at the right. We define our logic one time inside a function, and then we just call it with a single, clean line. I mean, this is really the difference between just hacking something together and writing professional, maintainable code.
Okay, so you might be wondering, how does Python actually know what code belongs inside a function? Well, the answer is a critical, non-negotiable part of the language, indentation. Yeah. Unlike a lot of other languages that use curly brackets or something, Python uses white space. That block of code that makes up your function has to be indented. If you get it wrong, you don't just get messy code, your program won't even run. You'll get a syntax error.
All right, so functions do stuff. Great, but what do they actually give you back in return? A lot of functions use the return keyword to send a value back to whatever called it. But what if you write a function that, say, just prints something to the screen? It doesn't have a return statement. What does it actually give back? Anything?
And here's the answer, and it's a really, really important Python rule. Every single function in Python returns something. If you don't explicitly tell it what to return, it will automatically return a special value called none. It's not zero, it's not an empty string, it's not false, it's none. It's just a placeholder for the absence of a value. Seriously, understanding this little detail, especially for exams, is absolutely essential for avoiding some really subtle bugs down the line.
Okay, so we've got the basics down. Now let's really supercharge these functions. We're going to look at how to make them way more flexible, way more powerful, and a whole lot easier to use.
So, when you're feeding data into a function, you've basically got two main ways to do it. The first is with positional arguments. Here, the order is everything. Python just assumes the first value you give it is for the first parameter, the second for the second, and you get the idea. But with keyword arguments, you actually label the values, like name equals user. And suddenly, the order doesn't matter at all, which can make your code so much easier for other people and you to read later.
But here's a classic problem. What if you have no idea how many arguments someone's going to pass to your function? Well, Python has you covered. By using *args, you can pass in any number of positional arguments, and Python just scoops them all up into a tuple for you. And in the same way, *args, that's keyword arguments, collects any extra keyword arguments into a dictionary. This is the secret sauce for creating incredibly flexible functions. And here's another awesome trick: setting default values. By giving a parameter a default value right in the definition, you make it optional. If the person calling the function doesn't bother to provide a value for it, no problem. Python will just use the default you already set. It's such a simple way to make your functions more convenient to use.
All right, so we've organized all our messy logic using functions. That's awesome. But what about when things inevitably go wrong? What happens when a user tries to divide a number by 0, or they type in hello where a number is supposed to go? That's where we build our safety net, using Python's exception handling.
So here's the key idea. An exception is an error that happens while your program is running, and if you don't handle it, it literally stops everything. Dead. The program just crashes and burns. Our goal is to catch these exceptions before they can bring the whole thing down. And the way we do that is with this awesome try-except structure. You put your risky code, the stuff that might fail, in the try block. If an error does happen, Python immediately jumps down to the except block, and that's where you handle the problem gracefully. Now, if everything goes perfectly with no errors, the optional else block can run.
And here's the really cool part. No matter what happens, error or not, the finally block at the end will always run. It's perfect for cleanup, like making sure you close a file you opened.
So, catching errors is one thing, but to do it like a pro, you really need to know what kind of error you're dealing with. Knowing the names of the most common exceptions is a core skill for any Python developer. So, let's do a quick pop quiz.
First up, take a look at this line of code. It's a classic. We're trying to divide by 0.
What's the specific name of the exception that Python is going to raise here? Take a guess.
Okay, quick. Here's another one. We're trying to convert the text ABC into a number, an integer.
What's the specific error name we're looking at in this case? Recognizing these patterns is absolutely key.
All right, how'd you do? If you guessed zero division error for the first one and value error for the second, you nailed it. And here are a few other common ones you'll run into all the time. A type error is when you mix things that don't mix, like adding a string to a number. An index error is when you try to access an item in a list that isn't there, and a key error is the same thing but for dictionaries. Knowing these by name is a huge advantage.
Okay, before we move on, just a few pro tips to keep in mind. First, be specific. Don't just catch a generic exception. Try to catch the exact error you're expecting. Also remember, this is for exceptional situations, not for your normal if-else logic. Always use that finally block for important cleanup. And please, provide helpful error messages so you or your users actually know what went wrong. So let's bring this all together. When you start combining these two powerful concepts, functions and exceptions, you really elevate what you're doing. You know, this is where we stop just writing lines of code, and we actually start practicing a craft. We start building solutions that aren't just functional, but are also elegant and truly resilient.
So if you remember one thing from all of this, let it be this. Functions are how you organize your logic. They make it clean and reusable. Exceptions are how you protect that logic. They make it robust and stable. The two of them, working together, well, that's the foundation of almost all high-quality software.
And that's really the question I want to leave you with. With these tools in your belt, you now have the power to move beyond just writing code that runs. You can start engineering solutions that last, that are robust, and that you can be proud of. Thanks so much for joining me.